So in this video, we're going to talk about quadratic inequalities. So far we've done linear inequalities, we've done absolute value inequalities, which are a version of linear inequalities, and now we're going to talk quadratic. So what you want to make sure that you have, and I'm going to scroll in on or zoom in on number 1 here, you want to make sure that all of your expression is on one side and a 0 is on the other. The reason we're going to do this is because I want to focus on being able to factor these problems, and so we want to have it in standard form or a factorable form. So I'm going to look at this left side, and I'm going to try and factor it. So I am trying to multiply to a positive 32 and add up to a negative 12. So negative 8 and negative 4 is less than or equal to 0. Now, I'm actually going to temporarily ignore the inequality sign here, and I'm just going to focus on what values would make this equal to 0. So my critical values, all right, so my critical values are going to be positive 8 and positive 4. Now, what that means is on a number line, I am going to put down my critical values of 4 and 8. And I am going to test in the other sections of the graph. So I want to test something that is less than 4. I want to test a number between 4 and 8. And I want to test a number that's greater than 8. It does not matter what you pick. Just don't pick the critical values themselves. Okay? And it doesn't even have to be spaced out evenly. So I'm going to put 0, I'm going to pick 6, and I'm going to pick 10. And when we test this, what you're doing is you're testing this value in the original inequality. Not your factored form, nothing to do with the critical values, but back in the original inequality. So if I test 0, I would have 0 squared minus 12 times 0 plus 32 is less than or equal to 0. Well, that's going to turn into 32 is less than or equal to 0. That is a false statement, all right? So what that tells me is this entire interval, all the numbers less than 4, don't work, all right? By testing this one value, you're actually testing the whole interval. So the next interval we're going to test is the numbers between 4 and 8, and we're going to test that by using 6. So if we test 6, okay, that's going to be 6 squared minus 12 times 6 plus 32 less than or equal to 0. So what I would do is just put this whole mess in the calculator, and that's exactly what I'm doing right now. Let's see, plus 32. That's negative 4. So negative 4 is less than or equal to 0. That is true. So that means I can shade between 4 and 8 on my number line. I know that interval, that section is true. I also want to test 10 and see if that works. All right, so test 10. Now, these tests, you do not actually have to write out. I'm just writing it out so you guys can see what on earth I'm talking about. Again, that's going to go this whole left side. I'm just going to whip into a calculator because, well, I'm going to. All right. So this is going to be 12 is less than or equal to 0. That is false. Okay. So that tells me that every number greater than 8 does not work. All right. So that doesn't work. The only thing you have left to do is on the actual critical values, 4 and 8, do you use parentheses or do you use brackets? So in this inequality, we had an equal to section, so that tells me I'm going to use brackets on both ends. So the actual interval here, that works, okay, are all of the values from 4 till 8. That's your answer. Okay, so again, you don't have to show me these 3 tests, but trying to verbally explain it without writing anything down seemed a little weird, so I went ahead and wrote it down. Okay, So that's problem number one, not too painful, especially, I'm hoping, all right, I should say I'm hoping, if you know how to factor really well, the factoring part should go pretty quickly, and then getting your critical values. All right, so moving on to number two here. We've got 6x squared plus 25x plus 14 is less than 0. I like the fact that it's in standard form. Not such a big fan of the fact that I have to do either advanced factoring, AC method, or my standby is guess and check. Again, I know I've mentioned this before. I've been doing guess and check for years, and so that tends to be my fall too. So for guess and check for me, I know that 6 is really 1 times 6 or 2 times 3. 14 is 1 times 14 or 2 times 7. And I'm trying to make a 25 here, so if I do, let's see, 3x, make that a 7, that's 21, plus 2 here and 2x there. Okay, so this is going to give me, I did do a quick check in my head, so 3x times 2x is 6x squared, 3x times 7 is 21x. 2 times 2x is 4x, so 21x plus 4x is 25x, and 2 times 7 is 14. Now, if you're looking at that and you still look at guess and check and you just say that is complete magic, that's fine. You don't have to guess and check. At this point, you have to be able to find the critical values. So pick your favorite factoring method, do something that works. You really could actually do quadratic formula here and get your critical values that way. All right, so critical values would be negative 2/3 and negative 7/2. All right, now fractions are one of the places that I know a lot of people get kind of weirded out about. Just be careful when you put them on the number line that you are accurate with which numbers are to the left or to the right. So negative 2/3 is negative 0.6 repeating. Negative 7/2 would be negative 3.5. So that one is further to the left. Okay. Critical values for me, we've got them labeled. Now I want to pick the numbers that I'm going to test. You have lots of options. If you have the option of picking 0, I highly recommend it. I'm also going to pick negative 1, and for giggles, I will pick negative 4. Okay, so the test, remember, is to go back to the original inequality and see if it's true or false. So if we test negative 4, we have 6 times negative 4 plus, oops, that's a squared, plus 25 times negative 4 plus 14. Now, we're testing to see if this left side is less than 0. Okay, if it is, great. We would then shade that interval. If it's not, then we don't shade that interval. So I'm getting 10 here is less than 0. We know that's not true. That's a false statement. So that means that this interval, all the numbers less than negative 7/2 would not be included in our answer set. So I'm now going to move on to the next one. I'm testing negative 1. Okay, so test negative 1. I don't know why I started a set of parentheses. Try that again. Let's see, negative 1 squared plus 25 times negative 1 plus 14. Again, you do not have to write this out. Okay, I just want you to understand what I'm doing when I talk about testing a value. Okay, so this whole mess right now is going in my calculator. So let's see where I'm at. Plus 25 times negative 1 plus 14. So this is negative 5. So negative 5 is less than 0. That is true. Okay, which means I would shade between my two critical values. I have one more test to do, which is my favorite test, and that's testing 0. Okay, again, if you have the option to test a 0, I highly recommend it. Okay, it generally works out either something that you could possibly do in your head, or it's just pretty quick to figure out. So let me see here, 0 here, and 0 with the 25. I'm pretty sure this is going to turn into 14. All right, it does. So 14 is less than 0. We know that's false. All right, so that tells me that this interval, all the numbers greater than -2/3, will not be included. So I know this is my interval right here. I just want to see on the boundary, am I using parentheses or brackets? There is no equal to here, so it is only parentheses. Okay, so all the way down here at the bottom, I'm going to put my interval, parentheses -7/2 to -2/3. Okay, so that is the interval that works for number 2. All right, I'm going to do one more in this video. This is going to be number 3. So for number 3, I notice right away, as soon as I get my pen color picked here, all 3 of the terms on the left side share a common x. What you want to be very careful is that you factor the x out. Do not divide the x out. If you divide by x, you will lose a critical value that will completely throw off your answer set. So I am going to factor out an x, okay, and then I am going to see if I can factor some more. So inside here, let's see, x minus 6, x plus 4, which will now give me critical values. Okay. So my first critical value is this lonely x outside here. This x gives me a critical value of 0. This next factor is going to give me a critical value of positive 6, and the last factor gives me a critical value of -4. So all of those are critical values of information. So on the number line, I'm going to put all 3 of them, okay? And again, in order, so -4 is my smallest, then I've got 0, then I've got 6. So I now have 4 intervals to test. From -∞ to -4, from -4 to 0 is another interval, from 0 to 6, and then the last interval is 6 to infinity. Pick anything in those intervals, all right? You could pick -512 as the number less than -4. It doesn't matter, all right? So I'm going to do -4, I'm going to do -2, I'm going to pick 1, and I'm going to pick 8. It doesn't matter. You don't have to pick those values. Again, the only thing you absolutely cannot pick are the critical values themselves. You don't want to do that, okay? So I'm not going to show the test in this case. What I will tell you is -6 is false. -2 is a true statement when you create it, so we would shade from -4 to 0. 1 is a false statement, and 8 is a true statement. So I'm going to shade from 6 to infinity. The last thing to check for here is at these boundaries, -4, 0, and 6, am I using brackets or parentheses? Because this is equal to, you need brackets. So bracket, bracket, bracket. Interval here, we're going to start with -4. We're going to continue to 0, and then union 6 to infinity. So that becomes our answer set for this inequality. All right, at this point I'm going to go ahead and close this video. There's 2 more problems that are a little bit different. I'll go ahead and do those as a separate video just because I know this one's getting relatively long. If you have any questions or concerns, send me a message with whatever you need help with.